Alrighty, boys and girls, so let's get ready for another math lesson. This is Chapter 5, Section 7, and this is Factor Linear Expressions. So with factoring linear expressions, basically what you're really doing is working backwards from everything that we've been doing with distributive property. So instead of multiplying, division, and what you're going to do is you're going to get a couple monomials, and you're going to try and look for something that they have in common. In particular, greatest common factor. So let's start out with an easy example. So let's say we had the numbers 36 and the numbers 39. So here's a little review, greatest common factor. So let's list all the factors of 36. Well, we know we can do 1 times 36 to get 36. We can do 2 times 18. We can do 3 times 12 and 4 times 9. And we can also do 6 times 6. For 39, we can do 1 times 39. And we can also do 3 times 13. So when we look for the greatest common factor, we look at all the factors, both of these numbers. Common factor meaning factors they have in common in both sets. 1 you're obviously going to have. We're looking for the greatest common one though. There's no 39s here, no 13s here, but we do have 3 on both sides. So 3 is the greatest one they have in common. So the greatest common factor here is 3. So let's say we had an expression here, and don't worry about PEMDAS for now. Let's just say we had 36 plus 39. And if I told you I wanted you to factor this, well, you would look at this and you would say the greatest common factor that these numbers have is 3. So you could pull that 3 out via division. And when I say pull it out, I mean outside of the parentheses. And 3 can be divided into 36 12 times, or you can say 3 times what number gives us 36? The answer is 12. 3 times 12 is 36. Here, 3 times what number equals 39, or 3 goes into 39 how many times? And the answer is 13. So the answer would be this right here. If we wanted to check our work, 3 times 12 is 36. And 3 times a positive 13 would be positive 39. Same thing there, so it checks. Now, you're going to be factoring expressions, and they're going to have 1 or more variables. So what you're more than likely to see on a test or a quiz would be this. Let's say, using the same numbers to make it easy, 36x plus 39. Now, if I told you to factor this, again, we already know the greatest common factor here is 3, so we would rewrite this as 3 times, and this time we wouldn't just say 12, because 3 times 12 is 36. We want 36x. So we would say 3 times 12x plus 13. And when we check this, 3 times 12x is going to equal 36x, and 3 times 13 is going to give us positive 39, so it does check. So let's do some more of these and make sure we have the hang of this. Let's do 12 plus 28c. Well, the greatest common factor that we have right here would be, let's see, 2 goes into both of these. 3 goes in here, but it doesn't go into 28, not evenly. 4 goes into this. 4 goes into that as well. 5 doesn't go into these. 6 goes into this, but not this one. So we're going to use 4. So 4 times what gives us 12? 3. 4 times what gives us 28? And that is going to be 7. But since we want 28c, I'm going to put a c right there. Now we'll check to make sure that we have the right answer. 4 times 3 is 12, and 4 times plus 7c would be plus 28c, so it checks. Let's try another one. Let's try 14 plus 21x. Well, here, the greatest common factor when you look at this is the number 7. So that means we can divide 14 by 7, we can divide 21x by 7. So, 7's on the outside of the parentheses. 7 times what gives us 14? 2. 7 times what gives 21x? 3x. And we can check our work. 7 times 2 equals 14. 7 times 3x gives us 21x. Same thing there and there, so it checks. Here's another one. Let's try with multiple letters. Let's do 15xy plus 25x. Now, when you look at the numbers, right away you should see, okay, 5 is the largest number that goes into both of these. But we also have a letter in common. So in addition to just 5, notice there's an x here and an x here. I can actually pull this out of both because I can divide x into both of these. So 5x is going to be on the outside of the parentheses. Now, what do I have to multiply 5x by in order to get 15xy? Well, to make the number 15, I have to multiply it by 3. 5 times 3 is 15. And to get the letter y there, x is already on this spot. So to get the letter y right here, I need to have a y there. There's my plus. And here, what do I multiply 5x by in order to get 25x? Well, 5 times 5 is 25. Since I already have the letter x here, I'm good to go. Now, let's check this and make sure that our answer is right. Here, we have numbers 5 times 15, or 5 times 3, which is 15, and we have the letters x times y, which is xy. Here, signs are same, so plus 5 times 5 is 25, and we have the x there, so we put the x there. And you can see we have the same thing here, so it checks. Let's do one more. Let's do 10x plus 25y. Now, again, when we look at these, the greatest common factor of both of these is 5. 5 goes into 10 twice, 5 goes into 25 twice. Let's look at the letters. I have an x and I have a y, but do I have an x in both terms? No, so I can't drag an x out. Do I have a y in both terms? No, so I can't drag the y out. Here I was able to drag the x out because I'm going to distribute it to both of these terms because an x was in both of these terms. That's why I could take that x out. But here I can't pull an x out because it doesn't go in both terms. I can't pull a y out because it doesn't go in both terms. So instead for this one, 5 is going to be out here, and 5 I have to multiply it by 2x in order to get this, and I have to multiply it by 5y in order to get this. To check my work, 5 times 2x is 10x, 5 times 5y is 25y, and that is factoring linear expressions.